So what is merge sort? Merge sort is a sorting algorithm that uses recursion and a divide and conquer method of solving the sorting algorithm problem. And so here we have an array of 8 elements, right? And what it's going to do is it's going to take the array, split them, then it's going to take a look at the left side, split those, take a look at the left side, split those. Once it reaches the base case where the arrays are of size 1, then it's going to return the array on the left side. Then it's going to consider the right side. It also reaches the base case where the array of size 1 is of size 1, so it returns the array. And when it returns, it sorts the two arrays, the elements in the two arrays. This one here is very easy to sort because there's only one element in each, and it places them there. Okay. Now this here has, now what it does is it runs merge sort on the right side, right there, right? And running merge sort on the right side is going to split the two in half, reaches the base case, so it sorts those two. Okay. And now that it's sorted those two, it's going to return the array and sort the two arrays. Now that it's done that, it's going to run merge sort on the right side, which runs merge sort on the left side, which runs merge sort on the left side, reaches the base case, returns back up sorting the two elements, runs merge sort on the right side, sorts those two elements, sorts those two arrays. And now that the two halves are sorted, it sorts those two halves. And what we get is a sorted array, right, with a time efficiency of n times log of n. And that's much faster than we get with insertion or selection, right? Especially for large data sets. So if we're talking about like millions of numbers, then we're talking about, I think, hours maybe, depending on the processor. So yeah, so that's merge sort, and this is the implementation of it. What do we have here? We have the if array is greater than 1, then do all of this. If it's not, then we return the array, right? So it's kind of like an if-else. This is if-else, right? And returning the array is like the base case, and this is a recursive algorithm. Notice here we're running merge and we're running merge, right? So we have a method that's calling itself. Let's assume that this array here is this array here, and this is true, right? All of this code here is splitting the array into two halves, into R1 and R2. Okay, and then and you can go ahead and take a closer look at the code if you want to convince yourself of that. And then once it does split them into two, then it runs merge sort on the left side. Okay, that's going to continue running merge sort on the left side, splitting it, running merge sort on the left side, splitting it, running merge sort on the left side, right? Because we're splitting right here. So it takes in the full array, splits it in half, runs merge sort on the left side. We got the left side here. It splits that half in half. It runs merge sort on the left side. Takes that half, cuts that half in half, and it runs merge sort on the left side. Okay, so that's what's happening. And then eventually, the array that's coming in is going to be of size 1. This is not going to be true, and it's just going to return the array of size 1. Okay. Okay, so let's go ahead and run through this. Reset. Run. Okay, so we take the entire array, that's right here. We split that in half, that's right here. Okay. Then we run the merge sort on the left half. Okay. What does that do? That makes array equal to the left half of the larger array, and this is true. It splits the array in half. That's what we're doing here. Okay, so this is R1 now, this is R2. and it runs merge sort on the left side, which splits it in half. And then it runs merge sort on the left side, which is an array of size 1 that's highlighted in green. So this is an array of size 1. This is not true, so we return the array of size 1, right? Okay, so then we come back up to where merge sort was called. Now R1 is equal to the array of size 1 that has this element in it. And then what's next is it runs merge sort on the right side, right here, right? So R array is equal to this array of size 1. This is not true, so it returns the array. Okay. So now R1 is equal to the array of size 1. The R2 is equal to this array of size 1. Okay. This algorithm here is sorting those two arrays. Okay. We have while loops because it's assuming that these two arrays are greater than size 1, but it also works for arrays of size 1. So what we're doing is we're sorting these two guys right here. Okay, so let's go ahead and do that. Okay, and then what does it do? It returns that array, right? It returns this array of size 2. So we get to there. Once it returns the array of size 2, then we're going to be coming to this merge sort call here to this right side. Okay. Now this is going to be a little bit different because R2 is now an array of size 2 elements, right? So it's going to call merge sort where array is going to be an array of size 2. This is going to be true, and it's going to split the two. It's going to split the array into 2, and it's going to run merge sort on the left side. Okay. So we split the array into 2. It runs merge sort on the left side. It reaches the base case, returns the array. It runs merge sort on the right side. It reaches the base case, returns the array, and then we come back to here and we sort the two arrays. Okay. Once that's done, it returns the array of size 2. Okay. Now that takes us right to here. Okay, so R1 is an array of size 2. R2 is an array of size 2. This is the left side, this is the right side now, right here and here, because what we returned to was this function call. Our method call we returned here. So array 2 is equal to this array, right? And what do we do after that happens is we run through the sorting algorithm, right? So we go ahead and sort those two guys. Now when that's finished, we return the array. So we're returning this sorted array, okay, which takes us back to this method call, right, with R2 being the right side of this original array that has been split. Okay. Now when we call merge sort here with this array of size 4, right, this array here that's coming into the method is of size 4, and this is going to be true. We're going to split that array into 2 pieces. Then we're going to run merge sort on the left side and the right side, and it's going to go through the same algorithm. Right, so this is recursive, so we're just kind of going through the same process over and over and over again. So if you were stuck in a room and you were asked to create a sorting algorithm for the first time, you would create insertion sort. You would create selection sort, right? If you had like 10 minutes to do it. If you were stuck in a room and you were given, I don't know, 100 years, right? You would come up with merge sort, right? This is just kind of a well thought out sorting algorithm, and it has a very high efficiency rate. You don't, for the exam, you do not need to know the details. They are not going to ask you to recode merge sort using a slightly different algorithm. You just need to know the general structure. You need to know that it's recursive. You need to know that it uses a divide and conquer. And divide and conquer means we're splitting the bigger problem set into halves, and then we're solving that half, right? It uses a divide and conquer methodology, and they might give you a merge sort type of multiple choice question. Okay, and if they do, you probably want to run from it. Probably going to be a black hole. Okay, and you're never going to see a sorting question in the free response. You're never going to see a recursion problem in the free response. So you don't have to worry about those two guys. But you are going to see the array lists, you're going to see 2 array list problems on the free response. So be prepared for that. Yeah, and that's about it, right? And another thing is, if you do decide to study computer science at the university level, then yeah, you're going to become very familiar with mergesort and also bubble sort and heap sort and all of those other sorting algorithms. So have fun with that.